Hello and welcome to the International Postdoc Forum for the Philosophy of Science, sponsored by the Minnesota Center for Philosophy of Science. My name is Alan Love. I'm the director of the Minnesota Center for Philosophy of Science and delighted that you are with us here today. Just want to say a quick word about this series, which began during the pandemic as a way to spotlight emerging scholars from around the world, and especially those who might have lost opportunities for presenting their research due to cancellations and restrictions on travel. However, due to the success of the series, we've continued it now beyond the pandemic as a way to spotlight those scholars in a continuing fashion. And we're excited to host them on an ongoing basis every semester, typically 2 per teaching term. Also, each of these has a commentator, somebody from the local Minnesota Center for Philosophy of Science community, and I will introduce that commentator later. But let me get to the main event. I'm delighted to introduce Cristian Larroulet Philippi, who is at the University of Cambridge, and his presentation today is entitled Quantifying the Human Values in Measurement or Measuring Value. Cristian, the floor is yours.
Thank you very much, Alan and Janet and Dana, for commenting. I'm setting up my slides. I hope you can see well.
Yes, they're coming through great.
Good. So this talk is part of a broader project that tries to understand quantification practices, both at when quantitative concepts are used just as conceptually as concepts, but also or especially when they are linked to empirical measurement procedures. Sorry for the noise. There's fireworks in here in Cambridge now. And the focus is in the human science, or the motivation is in the human sciences, but many of the things that I'll be discussing go beyond the human science, as it will be clear in the talk. So, but the starting point here is the idea that quantitative concepts and their measurements in the human sciences remain controversial. So what do I mean by human sciences? Well, I mean psychology, sociology, economics, and those areas of medicine that share the same measurement methods as psychology. What do I mean by quantitative concepts and their measurements? I'm referring to something like a theoretical property, right? Something that is postulated by the scientists in order to explain and predict phenomena, perhaps, and it goes over and above something that is more or less directly observable. So the idea is not so much that it's controversial that we can count, say, the number of correct answers in verbal tests, but rather whether we have thereby done enough for quantifying something that we would call reading comprehension. Perhaps a bit more controversial, but still it is less controversial to say that we can count depressive symptoms, but the meat here of the issue is whether we have thereby quantified something like depression severity, something that it would make sense to say that we have sort of represented as a unidimensional quantity. And in which sense it is controversial? I think if you read the literature, if you read psychometrics and many of the debates, you do get the sense that people don't agree on what kind of what is a success case of quantitative measurement in the human sciences. So there is an intuitive sense that it's easy to see that it's controversial. But let me motivate in 2 ways the worry that that alleged quantitative measurements in the human sciences actually aren't so. First is the more, I guess, metaphysically inclined worry that, well, are these really one-dimensional quantities? The kind of thing that it would make sense to put one number per object being measured. And one way of working that idea out is to refer to what Joel Mitchell calls the homogeneity concern or the quantity objection that I do discuss in this forthcoming paper in BJPS. But it's the idea that take length. So basically, increments of length are always increments in the same kind of thing. If they differ, they only differ quantitatively, but not qualitatively. That's why we can compare those amounts, but that is only possible because length is homogeneous, right? So different increments of it are of the same kind. That's why we can compare them. That's why we can say this increment is twice as big as this other one. Contrast that with, say, depression. This is a standard, perhaps the most widely used measure of depression severity. The Hamilton Depression Rating Scale, basically 17 questions. You get a score depending on the answer, and your total score is meant to be a quantitative representation, or is used as such, of your depression severity. And if you read just the first page here, you see that the kind of questions that they are asking are quite different. So depressive moods, feelings of guilt, suicidal thoughts and behaviors, and different kinds of problems for sleeping, for falling asleep, for staying asleep, and so on. So it would seem that some increments of depression are constituted by changes in suicidal thoughts, but other ones in insomnia. So it's not clear whether we are having here a situation in which changes are always changes that differ, if at all, in their amounts, but not in their kind, right? So that's the kind of worry that the quantitative objection raises. And the idea here is, of course, that this goes beyond depression, that this kind of situation is common across the human sciences. So we're actually not targeting attributes that could be represented quantitatively. A second way of motivating the concern that quantification in the human sciences is controversial is to think of the question of, well, which of the many instruments that we have, measuring instruments, are valid? So in the case of depression, there's more than 280 scales for measuring depression. And they are not all the same. They have, of course, some things in common, but the scoring rules and the exact symptoms that are asked, they are not the same. So the problem is not that we have many. The problem, it seems that there's not clear grounds that we can sort of refer to say, oh, this particular scale is the valid one, while these other ones aren't. But if so, then how is that we arrive in this situation, right, in the first place? And that's another way of motivating the worry. Right? Similar situation can be said happening in reading comprehension or happiness scales, health, human development, and so on. So that's the starting point. The plan for today is to basically do roughly two things, which is to sketch two plausible accounts of quantification. One account is going to be squarely within standard ideas in science. So it is an account that would address the two worries that I raised, and it would situate quantitative measurement within concept development, empirical testing, prediction, and scientific discovery. So it's meant to be a more explicit articulation of how quantification could get started in these cases in which it's not clear how to move forward. But in part because I don't think that is going to be useful for interpreting many of the practices, I want to offer an alternative account for interpreting practices of quantification, practices that try to put one number per object where those numbers are expressing amounts, right, distance relationships. And here the central role is going to be played by the idea of value. And what is being quantified here is value in some sense. So here we won't be expecting testing, prediction, and discovery, but rather the whole point of this might be more related to streamlining or standardizing policy decisions or regulatory decisions. And the bold claim, so before, what I should be doing is to show that these are sort of coherent, internally coherent accounts of quantification. But what I'll be trying to suggest, perhaps more boldly, though it's work in progress, is that this second approach, which is not what scientists are thinking of themselves as doing, actually has better chance of interpreting some of the measurement practices that we observe. And then I'll just quickly wrap up. So some preliminaries, these two accounts are not meant to be exhaustive, but they do cover sufficient ground because they are sufficiently different. There's enough meat there that is worth contrasting them to. I think it's pedagogically useful also. And they're also ideal types. So they claim that any particular measurement practice in any particular context and discipline is best interpreted by any given of these two approaches or other ones will never be a fully straightforward matter, right? But the point of articulating more explicitly these accounts is to help clarify what purposes could be guiding these practices, or could be more charitable, or could be guiding a more charitable interpretation of these practices, and in so doing also giving us resources for assessing these practices. So there's a dual ambition there of describing, but theoretically describing, and giving resources for assessing. And part of the motivation here is that as I see things, I see the debate very much stuck between people who don't see any possibility in human measurement attaining quantification, and people who don't see much of a problem in a way, or they recognize that there's a problem, but they're not too worried about changing their practices. So let's start with the first sort of scientific or standard scientific account. So, but recall the distinction, right? So between more or less directly observable properties, say the volume of mercury, versus the theoretical property that we are trying to measure as a quantitative property, the number of correct answers in verbal tests versus reading comprehension, right? And the question here that is very always present in these debates is, well, what's the relationship between these two, right? How does one infer from values of the observable to the values of the other one? But also, in which sense those theoretical concepts are meant to be something else, right, to what we can directly observe? Or what do we mean by amount of temperature if it is not amount of volume, right? Which it seems it has to be the case. I take it that a very intuitive and common way of thinking about the relationship between the observable measurement indications and the measurand, that is the attribute that we're trying to measure, is one that involves the notion of causation, right? So say, and this is what psychometricians call the reflective model. So say it is variations in the pressure X there, which that cause variations in the answers given to depression questions in depression questionnaires, that makes that those questionnaires are depression questionnaires, that makes those answers say a measure of depression, right? And this is very intuitive and common across the sciences to cash out the relationship in causal terms. But if we leave it at that, it's too general, right? In the sense that X could be ordinal, X could be nominal, and we could still picture a quantitative as a causal relationship, right? So the account that I'm trying to articulate more explicitly of how to get quantification going says, okay, we don't go with this bunch of items. Rather, we zoom in a particularly salient, say, quantitative effect that it's observable, or that is uncontroversially quantitative for at least in this setup, right? Such that we are going to try to understand X in terms of Y. So now X is the causal force behind quantity Y. And that already gives us more purchase, because we can ask, okay, what are amounts of X? And before it wasn't very clear how to answer that, but now we know that amounts of X are amounts of this causal force that we are quantifying relative to its effects on Y, right? So in a way, amounts of Y will be sort of isomorphic to amounts of X. So if that would be the approach, it would be something like, well, quantity X, if we ask, what is that cause behind quantity Y? But the problem here is that in our causally complex world, we know that Y is affected by many things, and many things that we won't typically want to lump as part of X. So say temperature, well, in early thermometry, arguably was thought as the force of heat, a causal force behind variations in the volume of fluids, say. But we know that volume of fluids were in our instruments were varying for other reasons that we don't want to lump as part of temperature. So the refinement is to say, well, this is a causal residual approach. So what we mean by X is that cause behind quantity Y, once we have control for the other factors that we, on background knowledge, stipulate as needing to be controlled for. And this notion of sort of residual, I take it from this historian of thermometry. The idea is that the working definition, the working characterization of temperature in early thermometry was something like, well, that cause behind the volume of fluids, but only after we have control for non-thermal effects, which of course is circular, right? But to specific effects that we don't want to lump as part of temperature. And the idea here is that we want to make sure that what we are attributing, right, of Y to X is just what we are that's what we are defining as X, right? And how we do that is by specifying, it's sort of a negative approach, right? We specify what we don't want to be, the variations that we don't want to attribute to X. And that requires specifying explicitly the confounders that need to be kept fixed. And the claim is that it goes beyond the case of early thermometry. It's actually a very common way of working out things. So take a radically different case. So Ramsey, truth and probability. He's figuring out how can we think of degree of belief as a quantitative attribute. He doesn't doubt that we can think of degree of belief in terms of introspection, but he doesn't see how that is going to lead us to a quantification of degree of belief, even only at the conceptual level. And he says, well, we go as physicists do, and we'll define it as a causal force behind something that is already quantitative. So in this case, degree of belief is what causes betting ratios, right, to vary. So different degrees of beliefs will lead to different betting ratios. But that's only after we have control for other factors that also, in our picture, affect betting ratios. Say, variations in our eagerness or reluctance to bet, right? So we want to attribute variations in betting ratios only to degrees of belief, only to the extent that those are not reflective of variations in eagerness or reluctance to bet. Take Charles Richter in the first paper trying to quantify earthquake size. As I read Richter, I think he's doing something in the same spirit, actually even more explicit. So he takes earthquake size to be the cause behind variations in a particular quantitative indication of earthquakes, which is the maximum amplitude recorded in a particular kind of seismometer, which is the one that he was working with, but only after controlling for other factors, right? Other factors that on background knowledge, we know that they affect also maximum amplitude. And in a way, here what we're having is a concrete specification of what amounts of earthquake size is all the variations that we observe in maximum amplitude, but once we have make sure that those variations are not responding to variations in this other thing, right? Now, if I leave it at that, it's rather like a static thing what I'm presenting. We're just defining a quantity in terms of its effect, specifying some confounders that need to be kept fixed to get the assignment right. But in which sense is this leading to testing, to discovery, right? So let me try to flesh that out, even if briefly. The idea is that we start with quantity X and we answer what is that? Well, the cause behind quantity Y. By having a measurement procedure that measures Y, say the volume of mercury, right? And specifying X as the cause behind the volume of fluids, and mercury is a fluid, we are already able to offer a test of the whole setup of the definition and the procedure, right? To take a famous historical example, take Hasok Chang's analysis of Henry Renault's experimental results, right? And this is in the context of asking whether we should be using air thermometers or mercury thermometers. So Renault does these experiments in which we have a bucket of water and we plunge two air thermometers and two mercury thermometers, right? And because on background knowledge, we expect those to be, that the measurement has the same value, right? For the two air thermometers is the same value. They should be giving the same reading. The fact that mercury thermometers don't give the same reading, air thermometers are more closer to give the same reading, points to a difference, right? That makes it such that there's variations in fluid in the mercury that we don't want to attribute to variations in temperature, because on background knowledge, that is a case where temperature is not changing, right? So the discovery there is that the type of glass is also making a difference, and that the type of glass is making a much larger difference to the reading of mercury thermometers than to the reading of air thermometers. So there's a sense in which there's a discovery of a confounder that has to be added into the definition, and that the new measurement procedure has to, now with the new definition, the measurement procedure that realizes that definition is the one that is going to be controlling for that confounder, right? So air thermometers approximate better the refined working characterization that came out of those experiments, which is temperature is what causes the volume of fluids to vary, but only after controlling for, not only for atmospheric pressure, but also for the kind of container. So the idea is that because we're specifying a concrete definition of the quantity, which is tied to a particular measurement procedure, we can test. By testing, we are bound to find disagreement. I mean, this is at the beginning of the road, right? And that disagreement leads to revision. And those revisions mean a different specification of the quantity, which then lead to further tests and further disagreement and so on. So that's the idea. And that is similar in spirit to what Victor Lenzen and Abraham Kaplan understand as successive definitions of quantitative terms or specification of meaning of quantitative terms. To sort of get a sense of what's the value of this, I think that sort of more explicit characterization provides three crucial ingredients. One is that there's a clear quantitative characterization of the measurement. So what is X? What are amounts of X? Well, amounts of Y, but not any old amount of Y, only those that cannot be attributed to these other things that we don't want to lump as part of the concept of X. Also, the working characterization settles what counts as a measurement procedure. You can ask, well, what is a thermometer? When do we adjudicate between measurement instruments that are giving different readings, right? A thermometer is any token instrument that approximates, or what metrologists call realizes, the characterization of temperature. That is, that its indications are believed to give only the residual increments in the volume of fluids, where residual depends on the characterization that we used, right? And there we got the basics. What is X and what measures X? And it's only then that we can test for agreement. And then it's only then that we can learn, because of course we are bound to find disagreement in the early stages or whenever we ask for more precision. Right? And this I take to be just articulating upon a point that is also very much present in Eran Tal's work, especially in this paper, Individuating Quantities. Unless we have some explicit definition of the quantity and an explicit link to a measurement procedure, we can test. How does our two initial worries get answered? Why should we think first of X as a homogeneous quantity, the increments of which are always increments of the same kind of thing? Well, because we are understanding X quantitatively as the cause of Y. That is, changes in X are quantified relative to the residual effects on Y. And Y is a quantity, hence it's homogeneous. So we are helping ourselves, right, to Y to understand X quantitatively. Why should we think that a given instrument is a valid instrument of X? Well, because that instrument is a token of the type of instrument that on background knowledge, we believe realize the definition on X, right? So that at least on background knowledge, we take those increments or variations to be reflective not of the kind of things that we have specified as confounders in our definition of X. And the third ingredient there is why this provides a clear road to progress. Is the invitation to test widely, right? The more we vary the conditions under which we are testing for agreement of, say, two token measurement instruments, right? In any context in which we don't believe that the measurement is changing, right? The more that agreement is symptomatic of progress versus just the mere lack of testing. And this is just the idea that, absence of evidence is evidence of absence, right? Only when we have search for it, right? To sum up, starting off efforts at quantitative measurement requires explicit characterizations of the attribute that connect directly to measurement procedures. And that is what I take to be the grain of truth that is present in operationalism. But there's clear differences between standard articulations of operationalism and what I'm doing. First, these characterizations or definitions are tentative, right? They are not fixed. Also, unlike sort of blunt conventionalism, they reflect scientists' background knowledge, and they are not, therefore, merely purely stipulative. And also, they enable overdetermination tests, hence they lead to empirical revision and progress. There's a clear sense in which we are able to test thanks to the fact that we are specifying the meaning. So we are specifying the meaning in a way that doesn't lead to success by default, which was a standard objection to operationalism, right? But rather that it has a clear path for testing and therefore for revision and progress. How would this go in the human sciences? Think of reading ability. Well, it would be that cause behind quantity Y, where quantity Y could be time to answer a given set of questions or the probability of correctly answering a given set of questions. but only once we have control for other factors that by now we know that affect Y. So we know that prominently the difficulty of the items affect Y, the anxiety and stress, which depends on the stakes of the testing environment, levels of noises, familiarity with test, pollution, nutrition, all these things we already have good causal evidence that affect Y. So we would only be in a position to assign values of Y to values of reading ability once we have make sure that those things are not varying. That would be the idea, right? And the idea, of course, is that what we mean by reading ability is just that, right? Is residual effects on Y. How would it go for depression? Well, it would be that cause behind quantity Y, where here Y could be the probability of committing suicide, or the time spent in negative thoughts, such as worthlessness, guilt, and suicidal thoughts and behaviors, right, or ideas in this case. But only once we have control for other factors that on background knowledge we take to ourselves to know that they affect Y as well. My claim is not that current measurement practices both of reading ability and depression tick the boxes of this approach. Rather, the claim is that this approach is one way of thinking about what it would take to quantify theoretical attributes in the human sciences, the kind of attribute that is controversial whether they are quantitative or not. Arguably, actually, most researchers are not pursuing this rather demanding exercise of testing whether they got the right sort of concept in the sense of the specification they need to provide and measurement procedures. And it's arguably difficult to imagine them succeeding, though I don't want to make that argument here. But take just perhaps the most promising case, reading ability or math ability, as that goes behind, say, the probability of correctly answering a given set of questions. It is not only the case that the list of confounders that would need to be controlled, right, for testing for agreement is really long, right? It's much longer than what I'm putting on the slide. But also, many of those items are in as much need of clarification as reading ability is, right? So difficulty of items is just the flip side of reading ability. Anxiety, stress, levels of noises. It's not that these are going to be straightforwardly operationalized and there will be we are going to be in a position to say, yes, here we expect the two readings to be the same, right? Which is what we require to then search for the reasons why they disagree. This at least motivates looking at alternative ways of understanding what researchers are doing. And that's what motivates looking at this more political project. And I want to sort of, one preliminary, I think that I should have said is that there's a default way of understanding measurement practices, which is just to say, well, they are not representing anything quantitative, right? You can think of Ted Porter's great book, Trust in Numbers, right? Where he emphasizes the role that numbers have in giving politicians who lost authority to have some authority because they can blame the numbers, right? If people don't like the decision of where the train is going to go, the train line is going to go through, they can blame the cost-benefit analysis made by the scientists because that is quantity, there's nothing to blame there, right? In that picture, it's not clear why those numbers would be representing something quantitative. So what I'm trying to do here is to see whether there's a political way in which there's another account where there is representation happening, even if it is not the same as I was just articulating under the causal residual approach. But let me motivate this value approach. It's definitely not what the scientists are thinking of their own work, right? So it's meant to be controversial to say that this better represents what they're doing, or it's a better tool for interpreting the practices. And let me motivate it with two observations. So one is that sometimes people seem to be interested in getting at the badness or goodness of, say, a configuration of states of affairs versus at that thing itself. So let me motivate with a natural science example, actually. So the Saffir-Simpson hurricane scale classifies hurricanes into 5 categories, depending on the wind speed, at least at the beginning. And we can ask, okay, but what is the measurand of this scale? What is meant to be measuring? Is size of hurricane in some sort of physical sense? And here, both critics and endorsers of the scale are very clear. No, that's not the measurand. That's not the property that we are intending to measure. It is something like destructiveness or potential damage of a hurricane to human-made structures. We can just lump that as just the badness of a hurricane. Further, sort of hints of why why this practice is after the value or this value of hurricanes rather than some sort of physical sense of hurricanes, is that when the author of the scale was asked why it has only 5 categories, right? Because clearly wind speed can continually growing after we have hit the 5th category. His answer was, well, basically we don't need a 6th category because by category 5, buildings are already vulnerable to be toppled or to be destroyed. So in a way, the way that I would put that is that destructiveness stops increasing even if wind speed doesn't. So that this is just to get across the idea that sometimes it seems that what we are after when we are putting numbers, even if this you think only as ordinal numbers, it's something about the value of the thing and not so much the thing itself. And there are other times in which we seem to be trying to put one number to an object or set of affairs where it's on the face of things, at least it's multidimensional. So it's not clear why it would make sense to put just one number as it does make sense if we're talking about a unidimensional quantity. And here I'm drawing a lot on Dan Hausman's book on health, valuing health. And his claim is basically the following, is that, okay, I see economists, health economists, allegedly measuring degrees of health as a quantity, departures of perfect health, some of them put it. But health, Hausman claims, it's multidimensional, right? So it's the efficiency of our various bodily parts and processes. And because we have various bodily parts and processes, it doesn't make sense to put one number to my overall profile of health. I can be doing better and worse with regards to my heart, better or worse with regard to my knee, with regard to my liver, but there's no sense in which I can say, you know, two bads in my heart and my liver sort of compensate for the bad in my back. But still, economists are asking people to answer those questions. What is more healthy to have what is less healthy to have a knee problem or a back problem? And people are answering the question. And what Hausman wants to suggest is that what people are really answering is not how more healthy it is. There's no sense of saying that. What they're really answering is how bad it is to have a knee pain versus a back pain in your circumstances from your perspective. So another way of putting this is that they're not trying to, they can't be thought as measuring quantitatively health, but rather the value of states of affairs constituting health. And that's the claim that Hausman, I think, very persuasively makes for these measures of overall health. And what I'm saying here is this actually generalizes. This is not specific to these measures of overall health. Now, you might be asking, okay, but what value, whose values, and why is that quantitative anyway? I mean, the whole project is about trying to understand quantitative thought, quantitative thinking, and our empirical procedures for gathering quantitative information. Value is not something that, you know, it's obviously quantitative unless you were trained as an economist, right? So let me distinguish between two notions of value. One, which I won't be focusing here because I think it's much more part of the scientific approach to quantification that I was mentioning before. And then I'll focus more in detail in this second one. So the first notion of value that one can have is one prominent among economists, which is the idea that, okay, we can postulate a theoretical variable, call it utility, right? That we postulate in order to explain and predict behavior. And that is value, right? And we reveal degrees of that value, how much people value different options, right? By observing their choices and by presenting choices to people, right? Presumably, that project requires testing, right? Whether people's answers are consistent enough given assumptions of stability, right, of the setups, and so on. And this is a project that has been pursued and arguably has failed, according to many commentators. But this is not what this is a version of the value approach, but it's much more in the camp of a scientific approach, right, where testing is key. I want to say that there's a different version of the value approach, which we can call the political approach, where value is not so much to be revealed by choices, but rather value is what we are deciding for making choices. And to get the idea, imagine a group of decision makers facing a recurrent allocation choice, a tough choice. So you need to allocate resources to different health centers that deal with different health problems, basically. So you need to do the difficult choice of how much resources are going to be given to different to addressing different health problems. And there's a sense in which there's no easy way of doing that. There's no common metric there, or not evident common metric there. And you can either imagine this group of decision makers doing that every season, right? Or deciding to standardize how they're going to do this. So they might decide to construct a scale that maps these health problems into priorities, such that the scale is going to represent their prioritization in a simple and accessible way. And there are arguments in political philosophy for doing that. I'm not assessing those arguments here, but rather trying to make the case that this is a coherent way of thinking what numbers could be representing. Numbers here could be representing the group's evaluative judgments about which health states are most significant for the particular choice context. So there's nothing here to be discovered, but rather something to be decided. But that it has to be decided is quantitative insofar as what needs to be allocated are resources, which are quantitative. So what do numbers represent here? They represent prioritization of resources, bigger number, more resources. And that's a sense in which we are getting a quantitative representation. We have a clear answer to what amounts mean here. Now, my claim is not that this is a good way of making policy decisions or, say, approving drugs, only that this is a plausible way of interpreting what people are doing when making when putting numbers to complex phenomena, right? One that, unlike Porter, does explain the meaning of the numbers as representing something quantitative, but is very different from what those numbers would be representing on the causal residual approach, and also that may be defended on political grounds in some contexts. Now, the bold claim is that this is not only a coherent way of understanding quantification, but also that it actually has a purchase in interpreting measurement practices that are controversial and therefore difficult to interpret in a way. So I think that an easy case would be the Human Development Index. So basically, it's a combination. We are forcing into one scale education, health, and income, and we are giving equal weight to each of them, and that produces a number. We can treat it as an ordinal number, or we can treat it as an interval measure, or an interval measure or a ratio measure, actually. Now, as old as the Human Development Index is the debate about the weights. So they are equal, but why equal, right? And you can also think, well, why unequal anyway? Like, it seems that the problem is not so much that they are equal, but rather that any weighting scheme seems arbitrary. And part of what I'm trying to channel is that, yes, unless we have specified what the measurand is, there's no way we can make progress on the debate of what the weights should be. So one way of specifying the measurand would be going through the first approach, right? Well, in that case, the Human Development Index would need to be postulated as a variable that we need for explaining and predicting, say, political phenomena. And in that case, presumably the weights would be empirically determined, right? Nothing of that we see being done by those who use the Human Development Index. I think much more plausible is the claim that what explains those equal weights, right, is a normative judgment, a judgment about the relative importance of health, education, and income when it comes to passing judgments of how developed countries are. That is the judgment that even if, say, the US is very rich, the fact that it doesn't score high in health, for example, it's a big issue when we are assessing development. And now that doesn't sort of justify the Human Development Index as a quantitative measure. I'm just sort of trying to argue under which account someone could be trying to justify a version of the Human Development Index, right? We will still need to know much more. Which choices, which resources are meant to be linked to this quantitative measure, right? I mean, the whole point of forcing a quantitative measure, forcing a combination of different things into one, right, would make sense to do it only if we need it, right? And so we need to be clear about that. And then there's questions of political legitimacy about that. But the point for me is that I'm trying to make clear which are the kind of questions that we should be asking about the HDI. And the claim is that, well, it seems that it's not the ones about testing and discovery. A more tricky case would be depression, because of course depression is a topic of research in science, right? Causes and effects of depression, how to conceptualize depression, theories about depression. But I want to suggest that even here, perhaps the value approach might have a better resources for making sense of the practice, or at least aspects of the practice. Basically, the Hamdi conceive of it as measuring a unidimensional causal force. I find it hard to square with what I see of the practice. All major measurements, not only the Hamdi, lump different kind of symptoms versus zooming in on a quantitative effect. There's evidence from factor analysis that those symptoms don't behave as being affected by one causal factor, but still there's no change in the measurement instrument since the 60s. There's no revision testing going on here. Also, a very common criticism of the Hamdi is that it gives too many scores to less central symptoms relative to more fundamental ones. For example, most prominently, there's only one question for suicidal thoughts and behaviors and 3 questions for insomnia, which makes then the case that actually patterns of insomnia changes much more the scores of the Hamdi than patterns of suicidal thoughts and behavior. And if you press Stegenga, which I've done, well, what do you mean by more fundamental? You would say, well, they're more highly disvalued. And I think that gives, clearly the answer that I'm looking for, right? That what is behind the Hamdi in the reading of Stegenga, even if implicitly, is something like the disvalue of depression profiles, right? Now, acknowledging, as I said for the HDI, acknowledging that the Hamdi scores might be better thought as expressing judgments of value is only a first step in justifying the Hamdi or a version of it as a quantitative measure of the value of depression. Right? We need to ask, okay, which decisions, whose values, right, for which purposes? So there's a bunch of questions that only get raised, but the point is that we are raising now the right questions, the pertinent questions, given how we can make sense of the practice. All right, so briefly taking stock, I've outlined 2 different accounts for making sense of practice of quantification. One focuses on discovering invariant quantitative relationships using this causal notion of negative causal or residual causal notion. And the other one, radically different, focuses on standardizing tough decisions in particular contexts. And here it's important to emphasize that the resulting numbers don't seem to be primarily of interest for the researcher interested in causes and effects, invariant causes and effects across contexts, because the numbers are tailored to particular decisions in particular contexts, right? And that's what makes them a little bit closer to policy, right? And less closer to issues of, again, testing or discovery. And the hope is that having at least 2 or more clearly distinguished conceptual possibilities may help with the analysis and critical engagement with quantification practices in general, and particular in the human sciences. Thank you very much.
Thank you, Cristian. So now I'd like to introduce the commentator for today, Dana Mathiasen, who is a postdoctoral research fellow at the Minnesota Center for Philosophy of Science. Dana, the floor is yours.
All right. These slides are visible, I'm guessing.
Yes, we can see them.
Okay, great. All right. Yeah, thanks to Cristian for the great talk. I'm just going to give a quick set of comments. First, I wanted to mention just some highlights that stood out to me from the work. One, I think this notion of quantification as an ongoing process of discovery and refinement is a valuable one. We've seen this in some work in history and philosophy of science in the past, including the stuff referenced by Chang, but I don't think this notion and this way of thinking of measurement always gets its due. I particularly like the idea that the characterization of a measurand is a dynamic process. We don't just start with one sort of stable concept of what we're measuring and just work with that throughout history. That gets continually refined and changed. Second feature I liked is that Cristian calls out or calls attention to the fact that there are many distinct forms of measurement practice and different objectives that motivate them within science and outside of science. Often, you get the impression that people are trying to give a sort of view of measurement as a single thing or as kind of falling under a single form. And so I like this move towards a little more pluralism. I thought the argument is convincing that the values approach should not be evaluated in terms of run-of-the-mill scientific measurements. According to Cristian's view, we're just kind of getting something wrong when we try to understand what, say, folks using the HDI are up to, if we think of them as sort of trying to understand development itself. And finally, I think there's a lot of room for fruitful interactions with the literatures that exist on values in science, science-based policy, and work on thick concepts. If I had enough time, I would prompt Cristian for comments on all of these things. But since I only have a limited number of minutes, I'm going to focus my comments to the two different kind of accounts and notions of measurement that we have here. So first, with regard to the causal residual account that is meant to be kind of the stand-in for scientific measurement in this presentation, I have three basic questions. The first one, is causation an appropriate encompassing sort of framework for understanding scientific measurement? Second, does this framework really resolve the kind of validity question that Cristian raised? And third, how seriously is this intended as a kind of historical or historically accurate account of measurement practices? So let's start with causation. Cristian frames the measure-and indication relation as a causal one. The measure-and is described as a causal force, and he says that quantity X is the cause behind Y. And my worry is that this may be too restrictive to make sense of various measures and measurement practices in empirical science. So I'll start with one example, inflation as measured by the Consumer Price Index. And so I'm just going to assume for the sake of argument that we can look at this as a form of scientific measurement. And as many people probably know, the CPI takes a kind of basket of goods, looks at the variation in prices of all of those different goods, and then kind of aggregates them to get an overall measure of inflation. And so if it shows an overall increase in prices, is it right to say that inflation, the measure-and, caused this variation in CPI? That's what one would assume from the kind of causal residual account of measure. But I worry that this is potentially reifying a concept, inflation, that's meant to summarize the effects of a range of different causal processes, which play out in a variety of different local market dynamics. And so it just seems a little strange to me to say that there's this thing, inflation, that's causing this change in CPI, rather than to be more specific and say there's a range of different causal processes that we're just sort of trying to summarize or aggregate and make sense of under this single term. And I think that some evidence for that is that when we aim to explain or alter inflation, we look to specific factors that might be affecting these markets, things like supply chains, money supplies, et cetera. But we don't look to intervene on inflation as some kind of independent cause, or even know how to do that. Okay, and I think this point can be extended to more like kind of natural science cases. I think we can find a lot of measures out there that have this kind of aggregative or statistical character in the natural sciences. One example might be fitness and population biology. There's some debate about this in the philosophical literature, but generally I don't think fitness is always understood in causal terms. That's at least debatable. And if we assume this kind of causal residual notion of measurement, it seems like it commits us to a particular interpretation of fitness and rules out kind of more statistical ways of thinking of it. Maybe even more simply, we can ask, is it right to say that length, regarded as a measure-and, is what causes variations in things like ruler readings? There's something that just intuitively strikes me as a little strange about that. And maybe the reason is that this leaves out the role of human activities, the coordinating practices and operations that are involved in aligning an instrument with some target. And yeah, whether it's just causation at work in this process of quantification is unclear to me. Okay, so to summarize, thinking of quantification causally might make sense in some cases, but I wonder about its scope with respect to a number of practices in science. That is, some quantities might be usefully regarded as causal forces, but others as informative constructs that aggregate, correlate with, or otherwise exhibit a flexible relationship with causal stuff. Okay, now on to validity. Cristian writes that an instrument provides a valid measure because it is one of the types of instruments that, based on background knowledge, realize the definition of X. And in an accompanying paper, he writes that to be valid or truly valid, measurement procedures should produce indications that are linearly related to the real property at stake. So if we know how to characterize the real property, if we knew that at the outset, then we wouldn't be going through this whole measurement practice. And this raises a question, well, that means that at the outset, background knowledge cannot provide the kind of validity that it seems is needed to respond to the validity question. So when do we achieve genuine validity? That's not totally clear from what's been presented in this framework. Nevertheless, it's one of the most interesting and challenging aspects of thinking about quantification. Figuring out which procedures can be reliably connected to a target. And this kind of relates to my last question, because I think in order to see how this process takes place, we need to look at the history of measurement practices. And I just wonder, how accurate a kind of like historical account is intended by this notion of quantification as kind of a straightforward linear process of characterizing some measurand and then refining our procedures to account for more kind of residual effects. For one thing, there's just many historical cases of measurement concepts that not only need to be reworked but like radically reconceptualized or thrown out altogether. Quantities of caloric, using physiological measures to get at race, eugenicist interpretations of heredity measures. These things show up, they live for a period of time, and then they have to get thrown out. And this kind of bucks the notion of just a kind of linear improvement of measurement. And so there's a question of how we think of such cases in this account. All right, so those are my questions for the causal residual account. I'm quickly just going to raise a couple more for the values approach to quantification. First, what exactly is the relationship between this multidimensionality, one feature that Cristian referred to as an element of the values approach, and this second aim of characterizing the goodness or badness of something? It seems like the value judgments, the need to encode value judgments, is clearly a necessary component of this approach. But it was less clear to me what its specific connection to multidimensionality was. And my worry is that these come apart quite easily. There's no special connection. So I'll give an example. Say I want to create a measure of the risk that some organism will develop a particular form of cancer. I might combine several different dimensions, things that don't seem to fall on the same sort of scale: environmental exposure, physiological indicators, comorbidities, and arrive at sort of a single quantitative measure to say, all right, this is the risk of developing this form of cancer. So it's multidimensional, but it doesn't in any way reflect a judgment about the goodness or badness of cancer. And this is relevant to some of Cristian's argument, because part of the argument for viewing the depression scale as a values-driven measure was its multidimensionality. He mentioned that this scale lumps different kinds of symptoms together that don't behave as if they're affected by one causal factor. And I would say this also applies to my cancer risk measure, yet I wouldn't include from that alone that it reflects value judgments. So I don't see the connection between multidimensionality and a values approach. I wonder, am I wrong? Am I missing something? Or do we see this kind of restricted view of scientific measurement influencing what counts as non-scientific or values driven? Okay, finally, just a question about whether quantifying the human is really the best or most appropriate way of framing what this work is up to. It doesn't seem to me that the values approach is characteristic of dealing with just the human. It seems to me like it applies to something broader, which we might call empirically informed policy and decision making, or something catchier if you can come up with it. So the hurricane scale is an example of, I think, and one of many different kinds of resource allocation questions that communities are confronted with that don't deal directly with quantifying the human. On the other hand, or conversely, many measures within the human sciences don't have this kind of values-based approach. So really the question is, what distinction in practices or subject matter does this difference between the causal residual kind of scientific measurement and values approach to quantification, what underlying distinction is this really tracking? And I'll leave it at that. Thanks so much.
Thank you, Dana. So now I want to invite Cristian to come back and briefly respond to a few of Dana's comments. Definitely don't have to respond to all of them. But before we have him do that, let me just highlight to those in the audience that we are going to shift to an open Q&A time immediately after that, so that if you have a question that you would like to ask Cristian, please go ahead and just use the raise your hand function. That will build a queue, and then I will be able to call on you to ask your question in a couple minutes when Cristian is finished with his response. So Cristian, go ahead.
Yeah, thanks, Dana. Great comments, and they get to the core of the project. So I'll, of course, can't respond to all of them. But I think basically I want to say, to stress, yeah, these two accounts are not meant to be exhaustive, right? So the case of inflation, I totally agree. It's not a case that is illuminated by the causal residual approach. Rather, the causal residual approach is meant to be articulating in more detail those theoretical terms that are characterized like as dispositions, right? So that they're always being linked to their effects, right? I don't know, if you define anxiousness in terms of what it leads to, well, that is the context in which we are working with. That's not the case of inflation. I think there are questions interesting about inflation. I think it's also not the case with fitness. And in those kind of cases, I think there's a genuine question there whether the measurements of those is just a conceptual relationship about defining what we mean. So the CPI is just a direct sort of, it follows just from the definition of inflation. There's nothing to test there. Or whether inflation is meant to be as a theoretical term that is going to play the role that macroeconomists want to play, right? In the trade-off between inflation and employment and so on. And that I see the same relationship with fitness, actually. Is it fitness? Are we going to define fitness as expected offerings, or are we going to define fitness as whatever is the driver of natural selection, right? But in any of those ways, the causal residual approach is not helpful there. And actually, I thank Dana for bringing up the case of fitness, because I actually think that a third approach that I've thought about hasn't made it into the text yet is actually motivated by the idea of survival fitness. So I think probability, as much as causation in relationship with a quantitative variable, probability itself is a way of quantitatively representing a property, even though that property is constituted by many things of different kinds of things. So I can increase my survival fitness by increasing the size of my lungs or the size of my legs, right? Those are not just the same kind of thing, but I'm combining them via probability. And I would take the example of the risk of cancer as exactly that. What that measurement is doing is measuring the probability of having cancer. And because probability is quantitative, if that is calibrated, right, to cancer events, then that's what we are measuring. And there's no mystery there. Why it is multidimensional, but not values. It is multidimensional in the underlying, right, the state of affairs that constitute the subject matter, but those things are being quantified relative to their predictions to an event, just like, say, survival fitness, in the way that if they would be measured by proxies of body and environment. I think I do want to speak, I mean, I can't respond to everything as I said, but the validity point, I think it's essential. I think there's something that should worry us about the idea that we observe a property, we hear about the property, say depression, and we have a bunch of measurement instruments, and we're wondering which one is valid. I think the framing that I want to provide is one that valid is not the same as successful. Rather, valid is something that should be clinched by the definition. And another question is whether the overall theory of the attribute, which is what gets at the confounders, right, that are also affecting the effect, right, but that are not part of the attribute, gets things right. So I want to say that valid now is cheaply obtained in a way, is whatever realizes the definition. But what is at stake here, what has to be tested, is not whether the instrument is valid, but rather the definition that we have covers the confounders that we are facing. And that's the sense in which I want to articulate the notion of validity. I don't know, I think I'm sort of over time now for the comments, but we can return to these points in Q&A as well.
Sure. Thank you, Cristian. So the floor is open for questions from the audience. Again, you can use the raised hand function if you have a question you'd like to ask yourself, or if you would like for me to read it out, I'm happy to do that if you use the Q&A function. Okay, first question is from Corey DeCheer. Corey, you should be able to ask your question.
Great, thank you, Cristian. This is really interesting, and it's good to hear you talk about it. I had a question about the sort of well, about why you're focusing on quantification here, I guess. So it seems to me that your account of quantification, this value-based account, is going to apply to a lot of things beyond quantification. Like there are a lot of non-quantificational measures that we could give that we might want to say, yeah, what those measures are doing ultimately is that they're allowing us to coordinate certain kinds of action problems in a consistent way. So do you think that's right, and that this account applies to something where I'm using smiley faces as opposed to numbers to quantify my pain or to measure my pain? Or do you think that there's something that's like very special about the relationship between quantification and values here?
Thanks. I guess my motivation is to grapple with quantitative talk. I think quantitative talk is present all over the place. I mean, in philosophy, right? Degrees of confirmation. Should we treat it as a quantitative thing? It's just a very tempting. The real line is just a very tempting metaphor, and so I don't reject, the idea that a value interpretation of some measures that are not quantitative might be interesting and important. I'm not sure about the case of pain, but one can think of, I don't know, cost-benefit analysis from an ordinal perspective, and what is that doing? Well, it's comparing apples and pears in terms of what we would value more, or what the people doing the analysis would value more. And if there's no commitment to quantitative representation, it would still be sort of illustrated by or clarified by the value approach. But I guess I am particularly interested in quantification practices, because I see so much disagreement about it, and so little way of making progress between those disagreements. So I found it interesting, and that's why I'm zooming in on that. But there's no claim that this is sort of restricted to that. Thanks.
Okay, thank you, Corey. So let's move to a second question from Maria. Maria, you should be able to talk now. Maria? Can you unmute yourself, Maria? Well, I don't know. Maybe Maria is having some trouble with the mute function. Oh, here we go. Maria? Oh, we're still not getting any sound. Well, Maria, if you're having trouble with your audio, maybe you can share your question in the Q&A function and we can tackle it that way. I'm not sure what the problem is, but sometimes there are difficulties in Zoom with audio. And while Maria's taking the time to type a question, let's see, does anybody else have a question? I don't have another hand yet in the queue, but maybe somebody is prompted to ask while we're waiting for Maria. Well, so maybe I will take host prerogative and jump in with a question of my own, and it's a little bit of a piggyback on things that both Dana and Corey brought up, and it has to do with the what we might think of as the difference between measurement and inference. So in a lot of these contexts, we are measuring something, and then we're also making an inference based on that measurement. And that's seemingly more common in these multidimensional cases, especially that we are, scoring people on the Hamdi test, and then we're making an inference about what the score on the Hamdi test is telling us about that individual. And this kind of gets at the why the tool is thought to be useful, even if the actual numerical value that is returned is not the most important thing. So similar to the hurricane scale, I think, where you highlighted that it's not somehow like the intensity of the hurricane as much as it's a measure of its destructive capacity. So I want to invite you to say a little bit about the difference between what might be called direct measurement and proxy measurement. So the idea that in some contexts we think I would like to measure something, but I can't. Maybe it's because it happened in the past and it's historically inaccessible. And so instead I measure something else. And I call that a proxy, and then I need to make some kind of inference from my proxy to the thing of interest. That's not exactly the same procedure as in the Hamdi survey, although you could potentially read what's going on in that survey as instead of measuring depression, what we're doing is we're measuring proxies for depression that allow us to make inferences or something like that. So I'm just inviting you to say a little bit more about how you understand difference between direct measurement and proxy measurement in thinking about some of the cases that you shared with us.
Yeah, thanks, Alan. Yeah, so I think at the core of my project is try to, and I think this has been part of the literature on measurement in the 20th century, where it's always been linked to concept development, especially in the logical positivist tradition. There is something about we trying to measure things that we don't really know what they are, other than what we are sort of what our measurement practices are telling us about. Right? The case of proxy measures that you are measuring is something that I take it that it would be a very different context to the one that I'm interested in if we know what we're talking about, we know what we want to make inferences about, right? We have an independent grasp on it, but we're using something else because we just can't measure the thing that we are after via its effects, which I guess is what we would be calling a direct measure, right? In the cases where the attribute is not observable, unlike length, say. So if the proxy measure is about something that we independently understand, then I think it doesn't raise, it raises inferential questions, right? So what's exactly the relationship? What kind of things can make that the proxy increases while the other thing doesn't? So under which consequences we couldn't make the inference, right? But there's no semantic relationship there, right? Because we have an independent grasp on the attribute. And the kind of things that I'm interested in is when actually we don't have, I mean, we do have a full sense, but if we're trying to quantify, then now we're coming up with a technical concept here. And then the practices of measurement are as much, in a way, giving us the meaning of the concept as an inference to the value of the measurand, right? So what I get worried is when we don't have an independent grasp and we're trying to measure something and we just call it a proxy to lower the standards, right? To lower the burden, right? It's just a proxy. We don't say that it's the thing that we are after, but then the thing that we are after is undefined, right? And I guess what I'm trying to articulate is that if we're really trying to quantify something, if we're never able to put ourselves in a position to expect to find two token instruments giving the same reading, then there's very difficult how to see. It's very difficult to see how there's going to be progress. There's going to be testing there. So proxy measurement, when we have an independent grasp on the concept, I think it's unproblematic. Proxy as a trick for lowering the burden, right, of what we're doing. I find it like that's exactly the kind of thing that we are like that is stopping us from making progress. Where progress doesn't mean we manage to quantify things. Progress can be, oh, we need to change our concepts, and this is part of what I should have also added in the comment to Dana, where I mean sometimes we just don't succeed in these. Actually, I have an independent project on earthquake size where it didn't succeed in the way that Richter envisioned, and now we measure quantitatively earthquake size in a different way. So I guess that is what I would like to say about proxy measurement. Yeah.
Yep. Okay. Thank you. I don't know, Maria, if you would like to try again and see if your sound works now to ask the question that you had. I'm not sure. You should still be able to unmute yourself and ask your question if you would like to. All right, I see Maria's unmuted, but I'm not hearing any sound. Huh. Well, Maria, I would encourage you to maybe type your question into the chat or in the Q&A function, and I'll be happy to read it out for Cristian to tackle. I've got one hand up in the queue. Actually, I'm not sure. Corey, do you have a second question? Or is that residual from before? Do you still have a question, Corey?
No, I asked my question earlier.
Okay, so it's just residual hand.
Sorry.
Just residual hand, not a problem. All right. Well, other questions, comments for Cristian to react to or answer? Well, if not, then I think we can bring our discussion to a close, I definitely would encourage people to look at Cristian's work, the forthcoming paper from BJPS and other papers he has on this topic. Thank you, Cristian, for taking the time to be with us and share your work. And thank you to the audience for being here. And thank you to Dana for the comments on Cristian's talk. For those who are interested in more presentations from the postdoc forum, you can find those on our YouTube channel where the recordings are posted afterwards. And we will be returning next year with some more installments. And until then, everybody can enjoy what's available online. Take care, and we'll see you soon. Bye-bye.